Today's notes are on 7.2, proving lines are parallel. So in 7.1, we learned about corresponding angles. Now, this is the converse of corresponding angles postulate. If two lines, so here's our two lines, are cut by a transversal and the corresponding angles are congruent, then the lines are congruent. So remember that corresponding angles are like same side, same position. So like right here, if 1 and 5 are congruent, then that means M and N are parallel. So if angle 1 is congruent to angle 5, then M is parallel to N. So in 7.1, we were actually going from this way to that. Next one, I'm going to go ahead and if I pick 2, what does 2 correspond to? 6. If angle 2 is congruent to angle 6, then M and N are parallel. I'm going to go ahead and pick 4 now. 4 goes with 8. If angle 4 is congruent to angle 8, then M is parallel to N. And then the last one would be 3 and 7. If angle 3 is congruent to angle 7, then M is parallel to N. Now, the converse of alternate, remember there are one's on one side, one's on the other. So one will be on that side and then one will be on that side. Interior means the inside right here. If two lines are cut by a transversal, and the alternate interior angles are congruent, then the lines are parallel. So right here, 3 is going to go with 6. They're on alternate sides of the transversal, and they're on the inside. So if angle 3 is congruent to angle 6, then M is parallel to N. And then we have right here 5 and 4. If angle 4 is congruent to angle 5, then M is parallel to N. Converse of alternate exterior, okay? Alternate means opposite sides of the transversal. Exterior means outside. So 1, 2, 7, and 8. So 1 is going to go with 8. If angle 1 is congruent to angle 8, then M is parallel to N. And then we have 7 and 2. Converse of the same side interior. Okay, so same side means they have to be on the same side of the transversal. Interior, so like right here, 3 and 5. If you look at 3, that's actually a small, and 5 is a big. Now recall, if you have a small and a big, they add up to give you 180. Those are called supplementary. So like right here, 3 and 5, 3 is a small, 5 is a big. If measure angle 3 plus the measure of angle 5, that is equal to 180, then that means that M and N are parallel. And then here we have 4 and 6. If measure of angle 4 plus the measure of angle 6 equals 180, then M is parallel to N. The transitive property of parallel lines theorem. If two lines are parallel and the same line to the same line, then they are parallel to each other. So basically, if these two are parallel to each other, let's say that this one is L, this one is M, and this one is N. So if L is parallel to M and M is parallel to N, then I can say L is parallel to N. If L is parallel to M and M is parallel to N, then I can say the top is parallel to the bottom. Lines perpendicular. Now remember, perpendicular means 90 degrees. So that little box, that's 90 degrees. Lines perpendicular to a transversal theorem. So here's our transversal theorem. Now that's 90 and that's 90. Those happen to be corresponding angles. If two lines are perpendicular to the same transversal, then they are parallel to each other. Why? Because it's forcing that to be 90 degrees and it's forcing that one to be 90 degrees. So I'm going to say this is L and this is M, and then this is our transversal. If L is perpendicular to T, that's this piece, and M is perpendicular to T, that's this piece right here, then L is parallel to M. All right. We are going to find the value of X that makes M parallel to N. So right here, I have a 140. 140 is a big angle, and 7X, that is a big angle. This is called corresponding sides. So this is going to be the converse of corresponding angle postulate. Our picture doesn't show parallel lines. So what do we need to do to make these parallel lines? We need to make sure that these two are corresponding angle postulate. Now, since that's a big and that's a big, I'm going to go and set them equal to each other. So 7X equals 140. Divide both sides by 7, X equals 20. On 2. These are on the same side. 3X is a big one, 2X is a small one. Big plus small equals 180. This one is called converse of the same side theorem. I'm going to go ahead and add these up now because remember, big plus small equals 180. So 3X plus 2X equals 180. 3X plus 2X is 5X. I'm going to go and divide both sides by 5. X equals 36. Now, these are on opposite sides. They're on alternate sides of the transversal, and they're exterior. So this one is called converse of the alternate exterior angles theorem. Now, these two are both small. They are equal to one another. So I'm going to set 9X plus 3 equal to 2X plus 38. Remember, whatever you do to one side, you're going to do to the other. I'm going to go and subtract 2X to both sides. So now I have a 7X plus 3 equals 38. I'm going to go ahead and I'm going to subtract 3 now. So now 7X equals 35. And then divide both sides by 7. So X equals 5. Now these are on alternate sides and they're on the inside. That's called interior. So this one right here is going to be the converse of the alternate interior angles theorem. And these two are going to be equal to one another. So I'm going to set 5X minus 1 equal to X plus 99. I'm going to subtract X to both sides. So I'm left with 4X minus 1 equals 99. I'm going to add 1 to both sides. So 4X equals 100. And then divide by 4. So X equals 25. So as long as X equals 25, this theorem applies. Now we are going to name all the angle pair relations that can be used to prove the two lines intersect a transversal are parallel. They're right here, 1, 2, 3, 4 on the first page. So let's go ahead and let's label those. So we have the converse of the corresponding angles postulate. We have the converse of the alternate interior angles theorem. We have the converse of the alternate exterior angles theorem. And then we have the converse of the same side interior angles theorem. A student wrote angle 1 and angle 2 are congruent. That means they're equal. So they're saying 1 and 2 are equal. Then by the converse of the same side interior angle theorem, they're parallel. That's not necessarily true unless they're 90 degrees. If I were to try to exaggerate this, watch, if I exaggerate my transversal line, you can kind of see this would be 1 and this would be 2. 1 is a big, 2 is a small. So these two right here are not the same. A big plus a small then doesn't equal, doesn't make the lines parallel. So right here, I'm going to go ahead and I'm going to say that the converse of the same side interior angles states that measure of angle 1 plus the measure of angle 2 equals 180 degrees. Not that angle 1 is congruent to angle 2. The only way would be is if they're both 90 degrees. Use the diagram below to answer questions 3 and 4. If angle 1 and 2 are congruent, so 1 and 2, that's alternate interior angles, which theorem proves? Well, there are alternate sides and they're on the inside. So this would be converse of the alternate interior angles theorem. If measure of angle 2 equals 4x minus 6 and measure of angle 3, okay, so these are alternate exterior. Alternate exterior are equal to one another. So right here, I'm going to say converse of alternate exterior angles theorem. Then I'm going to set 4x minus 6 equal to 2x plus 18. I'm going to go ahead and subtract 2x to both sides. So I left with 2x minus 6 equals 18. I'm going to add 6 to both sides. So 2x equals 24, which makes x equal to 12. Using the converse of the same side interior. So same side interior. So 1 and 2 equal 180. 3 and 4 equal 180. 1 and 3 equal 180. And 2 and 4 equal 180. Write two separate equations that would show that G is parallel to M. All right, so we'll say 1 and 3. If the measure of angle 1 plus the measure of angle 3 equals 180, then G is parallel to H. And we can also say 2 and 4. If measure of angle 2 plus measure of angle 4 equals 180, then G is parallel to H. And that concludes our notes.